Welcome to The Explainer. Today, we're talking about something pretty wild. What if you could take a whole team of specialized AI and literally merge them into a single supermodel? Well, a new paper gives us the exact recipe to do it, and you'll be surprised by how simple one of the key ingredients is.
So let's just kick things off with a little thought experiment. Imagine you've got a bunch of different AI models. One's a coding genius, another is a master poet, a third can crush any math problem you throw at it. What if you could just hit a team-up button and merge all of their brains into one multi-talented super genius?
Think of it like this. You've got a Lego kid for a race car and another one for a spaceship. They're both awesome on their own, for sure. But what if you could take the best parts from both, the rocket engine from the spaceship, the aerodynamic chassis from the car, and build something totally new, something way more incredible? That is the exact idea behind what we're digging into today.
Okay, so this isn't just some fun what-if scenario. In the real world of AI development, this idea actually solves a very real challenge, something we can call the specialist problem.
You see, the AI world is absolutely full of these powerful specialist models, but trying to manage a whole bunch of them is, well, it's a huge headache and super inefficient. The solution that researchers are getting really excited about is called model merging. It's literally the process of combining the internal wiring, the digital brains of these experts, to create one unified model that inherits all the skills of its parents.
And the process, at least in concept, is pretty straightforward. First, you take a base model and fine-tune a few different copies of it, turning each one into an expert on a specific task. Then, you use a merging algorithm to mathematically combine their programming. And what you get at the end is a single supermodel that can handle all of those skills, often even better than a model that was trained on all the data from the start.
And this visual just illustrates the goal perfectly. On the left, in Figure A, that's what you get when you merge just two experts. It's pretty good. But now look over at the model on the right, in Figure B, that one was born from merging 8 different experts. And you can see how its performance, that outer ring, is so much more balanced and powerful. It's a true generalist.
So here's the kicker. Up until now, most of this research has been done on relatively small-scale models. The huge question that this new paper tackles is whether that old playbook even works when you start merging the absolute giants of today's AI. We're talking models with tens of billions of parameters. Do the same rules even apply when you're playing in the big leagues? Well, to find out, researchers went all in. They ran over 9,000 experiments, and what they came back with is a brand new recipe for merging these giants. And it really just boils down to 3 key rules.
Okay, rule number 1. Your starting ingredients are absolutely critical. The research found that you get way better results if you start with what are called instruction-tuned models. These are basically AIs that have already been trained to be really good at following human commands. A solid foundation just makes the final product so much better.
The second rule is incredibly simple. Size matters. A lot. The experiments proved, without a shadow of a doubt, that when it comes to model merging, bigger is definitively better. The larger the base model you start with, the more effective the merge is, and the more capable that final supermodel becomes.
And you can see that plain as day right here in this chart. The blue bars are the smallest models, at 1 billion parameters. The orange ones are 8 billion. And those green bars? Those are the 64 billion parameter heavyweights. Across the board, performance gets a massive boost as the model size goes up. The big models just have more capacity to absorb and integrate all those new skills.
And the third rule follows that same kind of logic. Don't just merge 2 or 3 experts. The more you can bring into the mix, the better. The paper shows that merging a larger number of specialists leads to a final model that's not only better at those specific tasks, but also gets much better at generalizing to completely new problems.
And the data once again backs this up completely. As you move from left to right on this chart, increasing the number of experts you merge from 2 all the way up to 8, you see this clear upward trend in performance. Each new expert adds another dimension of knowledge, making the final model more robust and versatile. Now we get to what is, for me, the most exciting and kind of counterintuitive finding in this entire paper. It's a discovery that could completely change how developers approach building these powerful models.
So you'd think that merging the complex brains of giant AI models would require an equally complex method, right? I mean, people developed algorithms with fancy names like ties, merging, designed to do just that, carefully sort out any conflicts between the experts. It seems logical. But what if the answer was much simpler? Well, check out this data.
At the massive 64 billion parameter scale, the simplest method of all, and I mean literally just averaging the numbers in the model's parameters, performs just as well and sometimes even a little better than the really complex, expensive methods. The blue bars, representing that simple averaging, are right up there with the others. It's kind of wild.
This quote from the paper just sums it up perfectly. This is a huge finding. It means creating these incredibly powerful merged models doesn't require some bespoke, complicated algorithm. The researchers think that at a large enough scale, the models are so flexible that a simple average is all you need to combine their knowledge without causing any problems. That's a massive win for efficiency and accessibility.
So what does this all mean for the future? Why should you care about a new recipe for merging AI models?
Well, it matters because this research gives us a clear, practical, and surprisingly simple playbook. It makes creating these powerful, multi-talented AI models more efficient, which helps lower the huge cost of AI development. It unlocks better zero-shot generalization, which is just a fancy way of saying an AI can solve problems it's never seen before. And maybe most importantly, by showing that simple methods work best, it helps democratize the whole process. In essence, we've figured out how to go from trying to manage a whole orchestra of individual specialist musicians to creating a single, brilliant conductor who has completely mastered every single instrument. This research is like a blueprint for creating AI that's not just a collection of skills, but a truly integrated intelligence.
And that leaves us with one final, provocative question. This isn't just theory anymore, it's a practical guide. So now that the recipe for creating AI supermodels is simpler and more accessible than ever, the only real question left is, what incredible things are we all going to build with it?